3-2 in Advanced Algebra 2, we solve in systems right here. There are more than just solving in systems. We've got linear systems. Today we'll talk about some nonlinear systems where we'll graph stuff that are not lines. You know, they may be parabolas, they may be absolute value v's, they may be whatever. The system, long story short, two different equations, we want to know when they're the same. When would they be the same? When they intersect on a graph. It's like where the green one intersects the red one. When you graph two lines, they can intersect either in one place, in every place, or in no places whatsoever. So we classify those also. If you get solutions, we call that consistent right here. So kind of notes that's typed out for you, but consistent means that you got answers. So like here, didn't I get an answer right there? That system is consistent. Here, aren't there answers to this one? Aren't there infinitely many answers in this one? So I get answers, that's called consistent. This guy, those lines are parallel, no answers, meaning that's inconsistent. Okay? Then about how many answers did you get if you got answers? If you get one answer, that's called independent. Independent's pretty easy to recognize after we do a few of these, because when you're independent, aren't you all by yourself? Right? Independent means there's only one answer. If there was answers, but there's more than one, like infinitely many answers, that's called dependent. And then if there were no answers, then it's just plain old inconsistent. So grab that 3-1 homework that we had about systems, like I told you you'll need, and let's go ahead and classify all of these. You can check as we go along to see if you got them right, because these are the answers to it. Here's the first system. We graphed these two lines. We got an answer of -3, 3 is what you should have got. Grab your pencil and let's classify. Is this guy consistent or inconsistent? Did we get answers? Did we get any answers, yes or no? So consistent or inconsistent? Consistent. Down by your answer blank or somewhere. Then, since it's consistent, I need to then realize, is it independent or dependent? How many answers did I get? One or infinite? Come on, let's go. How many did I get? One or infinite? How many answers did I get? One answer, right? Is that independent or dependent then? That's independent. Boom. Consistent and independent. Classifying the system. Cool? Do that to the next one. How many answers did you get on the next one? Next, number 2, right? Do you know what I'm talking about? I'm on problem 2 here from your homework. How many answers did you get? You got no solution. So is that consistent or inconsistent? That's inconsistent, baby. The next one is inconsistent. Since there are no answers, then you do not say independent or dependent. Cool? Do that for the rest of the problems on this page. Number 3, since there were infinite solutions, there are answers. It is consistent. You cool with that? Since there is more than one answer, there's an infinite amount of answers, that's called dependent. Because x depends on y, or vice versa. Y depends on x. There's an infinite number of answers, but this is not an answer to the system. This is not an answer to the system. This one's not either. It's any point that's on this line. Well, how does the line go? Well, give me an x value, and how would I figure out y? I would say, well, take -4 times that and then subtract 2 away. Isn't that how you figure out what y is, right? I give you an x value, you substitute that number in for x, and it'll tell you what y is. That's what this is all about right here. Pick any x you want to in the world, and I will figure out y by using this little formula right here. And those are all the solutions to this puppy. This guy, consistent and independent also, right? There was an answer, so it's consistent. There was only one answer. Let's go to the back side. You can do it on ones that you don't graph either. Did you get an answer? Yes or no? If you say yes, that's consistent. How many answers? Was there one answer or infinite answers? So classify just those top 4. 5, 6, 7, 8 on the back side. Classify them. There was an answer on 5, so that's consistent. Since there was only one answer, that's independent. Same thing with 6. One answer, that's consistent and independent. 7, there was infinite solutions, so it's consistent. but that means it's dependent since there's an infinite number of answers. And then this guy had no solutions, so he was inconsistent. You okay with classifying a system? Well, let's do that now on number 1, back to our practice sheet for today. First thing they're asking us to do is solve these by graphing. But we're going to use a graphing calculator instead of actually making a graph. So let's realize we want to put these in our graphing calculator. But before I can put this in my graphing calculator, what do I have to do to these equations to even type it in? Solve for y. So let's take this guy over here and let's solve him for y. I would have negative 5y equals negative 2x plus 10, right? Subtract the 2x from both sides. Then I need to divide by a negative 5. Right? And then the other guy, now I want you to think, before we even punch these in, will they intersect in one place, infinite amount of places, or no places at all? How would you know if they were in no places at all? What would they be? They'd be parallel with the same slope. Are those parallel with the same slope? If it was infinite, they'd be the exact same equation both times. It's not. Shouldn't we get one answer to this? So let's make a rough sketch. Let's punch them in. First guy was 2/5 x. Put the 2/5 in parentheses. Minus 2. Second guy was negative shui x plus 15. Will the standard window fit? Just think about it. In this blue equation, will the standard window fit? It's got a y-intercept of 15. So let's go 20s all the way around and see what happens. And that's the rough hit. There's the first line. There's the second line. What am I looking for when I solve this system? Let's make a rough sketch of this, by the way. Now, check this out. Let's pretend this was your OneNote. Look how I make my rough sketch. First of all, I should have arrows. What did I do? First of all, when I solved this equation, I used green. Then I solved a completely different equation. Didn't I switch colors? You with me on that? When I graphed them, the green one I made green, and the blue one I made blue. I'm asking you to do that on your homework. You have the ability to switch colors now, right? So do one of them in one color, whatever you choose. Do one of them in another color, whatever you choose. Graph them in their corresponding colors. What am I looking for when I solve a system? What am I looking for? The intersection point. Find the intersection point. Second, calculate. Which option? 5. First curve, hit enter. Second curve, hit enter. Guess. Get that cursor somewhere in the neighborhood. Boom. 5, 0. So I have a very bad sketch. I'll try to make a better sketch next time. 5, 0. Awesome. Classify this. Is he consistent or inconsistent? Did I do something wrong? Everyone's looking at it funny. Are we okay? 5, 0. Is it consistent or inconsistent? Why is it consistent, guys? I got an answer, right? Now, how many answers did I get? 1 or infinite? 1. So that means it is independent or dependent? Independent, all by yourself. Consistent and independent is what that guy is. We cool with that? Next guy. They want us to solve by graphing. Top dude's ready to rock. Bottom guy, let's get him in slope-intercept form. Right? Maybe you grab yourself a green highlighter on your OneNote and highlight that guy green and then do the work in green so you know who's who again. Whatever makes you more comfortable. The top guy, I'll call him the red fella, is this. before I even graph this. One solution, no solutions, or infinite solutions. They have the same slope, correct? Right? Are they the exact same line, though? So it's not infinite solutions. How many solutions will this have if they have the same slope? No solutions. I don't even need my graphing calculator to make a sketch of this. I know what y equals negative 3x looks like. What's the y-intercept? 0. What's the slope? Negative 3. So shouldn't it look something like this? Shouldn't it go down from left to right and go through 0 on the y-axis? Make a sketch of y equals negative 3x plus 2 without even using a graphing calculator. You know the y-intercept and you know the slope. Shouldn't it be about like right there? You with me on that? And then how many solutions? No solutions. Why? Parallel lines. Same slope. Cool. There's no solutions to this. Meaning they never intersected. Right? Never intersected. Because they were parallel lines, had the same slope. Consistent or inconsistent? Inconsistent. And then you don't answer anything else since there were no answers. Next. Top guy, he's good to go. Bottom guy, put him in slope-intercept form. First guy in green, y equals x minus 5. Second guy, when I solve it for y equals x minus 5, you can know the answer already. One solution, no solutions, or infinite solutions. It's the same line both times, right? I don't need a graphing calculator to sketch that, man. It's y equals x minus 5. Y-intercept, negative 5. Bless you. Slope of 1. Will that thing go up or down as I go from left to right? Up. Answer, infinite solutions. Right? It's the same line both times. In the form, make an ordered pair. Ordered pairs always go x, y. We're always going to have x be x, and whatever y equals, I'm going to put that in that spot. I will not write y equals x minus 5. What does y equal in terms of x? Y equals x minus 5. So don't put a y equals part in there. But this is saying, hey man, any ordered pair, if I give you an x value, right, pick anything you want to, then if you subtract 5 away from that, that will be a solution, x comma y, every single time. Consistent or inconsistent? Consistent, because there were answers. Since there was infinite answers, is that independent or dependent? Dependent, right? Y depends on what x was. Awesome sauce? Nice. Uh-oh. Is this a linear scenario? Let's go to the calculator. Y's by itself in both times. Clear everything out. To type that absolute value in again, it is kind of weird to remember how to do it. The easiest way is we go to second catalog. It's right above your 0 key, second catalog. It's the first option in the catalog of stuff. It's ABS. You can literally type in ABS with the alphabet keys and then the parentheses also. 2x minus 4 goes in there. Right. Then the other guy, negative x squared plus 4x, don't graph it yet, plus 2. I want to think about what they look like before I even graph. This guy, absolute value, looks like a what again? A V, open up or open down in this case. It opens up because the number in front of the bars is positive, right? It did not get reflected over the x-axis. This guy is a quadratic equation. What do they look like when you graph them? Parabola. Will this guy open up or open down? Down, because the a value is negative. Let's zoom fix him and see what we get. We want to see if we see all the places of intersection. There could be more than one answer. Couldn't that parabola intersect that absolute value v in more than one place? Does it happen? And we found a bunch of those in the previous 2 chapters with our calculator, correct? Let's make a sketch of that again. Again, use 2 different colors when you're sketching on OneNote. Here's my V. Looks something like this. Here was my parabola. It looks something like this. This is not the kind of sketches we were making on our test where I give you the window and I'm asking for an accurate sketch. We're just looking, what do they look like in general, kind of sort of in the ballpark, and then let's find the solutions to this system. Isn't that where they intersect? So first curve, enter. Second curve, enter. Guess, my cursor's close here. So, nasty. How would we round then? Let's go, I don't know, 2 decimal places. So, did I type it in right first? Is that the right? Double check. Absolute value 2x minus 4, negative x squared plus 4x plus 2. Yep, I'm down with it. What was it? 0.35 what? 0.42-ish. And how do I make it approximate? You put it on the outside of the parentheses. How about that other guy? Second, calculate. I'll let you find him. Too many people are watching me do this. You can do this. Find that other place of intersection. So this guy was at about 3.64 or 65. 3.64 or 3.65? 5, 3.29. 2 different solutions to this guy. Was not linear. Consistent or inconsistent? Did we get answers or did we not get answers? So consistent or inconsistent? Then when it comes to independent or dependent, it's about, did you get a finite amount of answers, meaning you can count them, or an infinite number of answers? Did we get an infinite number of answers, yes or no? So is this independent or dependent? This is independent. Independent means you can count them up. I got 2 answers. Right? Even though that's more than 1, right, it's countable. Right? Independent is for countable, dependent is for etc. Now, even though you'll have a graphing calculator on this test, notice how it tells you to solve this system. No more sketches, no more intersecting. It's time for algebra, baby. We need to solve using the substitution method, then classify each system. Substitution method is when you've got a variable all by itself on one side of the equal sign. Do we have that going on? Think about it. What shape would this guy make right here? The green guy, what would he be? A parabola. What shape would this guy make right here? He's a line. Let's think about possible scenarios. I could have a parabola and a line that intersect in 2 places. Couldn't that happen? That could happen, yes or no? Is that possible? I could also have a parabola and a line never intersect. Isn't that possible also? I could also have a parabola and a line touch in one spot. Nice little bend in my line there. If it touches at just like the vertex or something. I could get no answers, 1 answer, or 2 answers possible. Can I ever get 3 answers? Is it possible for the line and the parabola to cross in 3 different places? It's impossible. It would have to curve for that situation. So just thinking what my possibilities are. Cool. Let's do some substitution. Let me get rid of this. Where there is a y, would you believe that this is what y equals? Why don't I substitute that in for y right down here then? Cool. Wouldn't that mean that x squared minus 5 equals x minus 3? Is everyone down with what I have done? Now look at this red equation. Is it quadratic? Yes or no? Yes or no? Why is it quadratic? I got a 2 for the biggest exponent. Get it equal to 0. Keep x squared positive if possible. Wouldn't I have to subtract this x over? Right? And then add 3 over. What's a negative 5 plus 3? And that equals 0. You with me on that? That guy is in standard form now. We cool? Let's see if I can factor him. Is there a GCF I can take out of this bad boy? Yes or no? Nope. What's the A value? 1 or not 1? Let's see if we can find two numbers that multiply together to be -2 and add together to be -1. Tell me about the two numbers, both positive, both negative, or one negative. One negative. So multiples of 2 right here, one of them has to be negative. Wouldn't that guy, if the 2 was negative, wouldn't those numbers add up to be -1? Right? So this guy factors easily, right? He's easily factorable to x plus 1 times x minus 2 equaling 0. Y'all down with that? Now, what does x equal? X could equal -1 or 2. Cool? Now you think, are we finished with this problem? I wanted to know the answers to this system. I got some x values. Aren't all the answers to our system ordered pairs? X, comma, y, right? So what do I still need? I need the y values. So here's what we'll do. We'll squiggle, 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 and we'll say when x equals -1. There's two different situations. X could be -1 or x could be 2, right? Totally two different things. How do I find y? I'll substitute back in. Who would you want to substitute back into? The green one, which is quadratic, or the blue one, which is linear? Which one would you rather substitute back into? The blue one. Let me put -1 in for x. Wouldn't that be y equals -1 minus 3? Right? All I did where there was an x, I put -1 in there. What's y equal, baby? -4. Stop and write yourself an ordered pair right away. -1, -4 is one of those solutions. When x was -1, y turned out to be -4. Cool? Then squiggle, squiggle, squiggle again. New set of work. Please tell me what you're doing. You're saying when x is 2. Wasn't that the other x value? I used him, right? Cha-ching! I found what y turned out to be when x was -1. Now when x is 2, I need to figure out what y is. Y will equal, put 2 in for x, 2 minus 3. What's 2 minus 3? -1. That ordered pair was what? What is the other ordered pair? 2, 1. I got how many answers to this system right here? 2, -1, thank you. How many answers did I get? 2 answers. Is it consistent or inconsistent? Dependent or independent? Now that was just one example. What I'm looking for when you take your homework quizzes and tests and even on your homework is all of this work. But hey man, I mean you'll have a graphing calculator in front of you. Check it out. I graphed them both. How many answers were there? 2, -1, -4, and 2, -1. Weren't those the two answers that there were? But we're going to do the algebra behind it. This is what I'm looking for. That graphing calculator can let you kind of check, did I get the right two answers in this situation? So let's do another one of those, baby. Top guy is a parabola, correct? Bottom guy is a line. Is there a variable all by itself on one side of the equal sign? So let's say, let's put a box around him. You do not need to solve the other equation for y. You already know what y equals. It equals this blue box. So take that blue box and substitute it in for y into the second equation. Is there any coefficients in front of y? Is there doing like a times 2 or anything like that? So you don't really need to put anything in front of that. It's -x² minus 2x plus 6. Then continue writing this equation, minus x equals 2. All I did was rewrite this red boxed equation right here, but where there was a y, I put what was in that blue box in its place by substitution. Y'all cool with that? This equation right here, is it quadratic? Yes or no? Yes or no? Is this equation quadratic? How do you solve a quadratic equation? Our first option is to factor it. Is this in standard form? Nope. These guys are like terms. Are they on the same side or different sides? Combine like terms when they're on the same side. Negative x squared minus 3x plus 6 equals 2. Right? Is that in standard form? Nope. I need to subtract 2 over. Yeah. Is it equal to 0? Yes or no? This is in standard form. We don't like it, but it is in standard form. Ax squared plus bx plus c equals 0. Why don't I like it? I don't like that. Did you like that? The a value is not 1. Can I easily do something to this equation to make that turn into a 1? What do you want to do? Take everything times negative 1. Right? Wouldn't that change all the signs? Math magic, baby. Solve that green equation by factoring. Please pause the video, factor that. When you're done, come back to me. 4. I factored this. Negative 1 and 4 add up to be 3 and multiply together to be negative 4. So I factored like so. Got these. Halfway home. Now time to figure out what y equals. So when you put the squiggle, that kind of tells me, A, I'm doing a different set of work now. You can also change colors. That's also a good way to realize, hey, I'm doing a different set of work now. You have two different scenarios. First, you must put up here which scenario you're dealing with first. If x is 1, right? If x is 1, I want to figure out what y is. You have either choice of these equations to substitute back into. Top one or bottom one, who would you rather substitute into? Bottom one, right? I don't want to deal with that quadratic at all. I want to deal with the linear guy. So y minus x equals 2. Right? Wherever there was an x, I put 1 in because that's what 1 is. It's the x value. Add 1 to both sides, y equals 3. Then immediately go up and write an ordered pair where you're going to put your answer. 1, 3 was one of the ordered pairs. Then squiggle, squiggle, squiggle again. New work. You're saying x is negative 4. So y plus 4 equals 2. Right? If you put a minus 4 in there, turns into a plus 4. Y equals negative 2. So the next ordered pair was negative 4, negative 2, right? X comma y. How we feel about that? It's a lot of multi-step process. First you got to solve. First you got to substitute, then you got to factor, then you got to solve, then you got to substitute those back in. Then you got to classify the system. Classify this puppy. He is consistent because we got answers. He is independent because we have a finite amount. That means you can count them. Finite. Infinite, you can't count to. Finite, you can count to. Okay? Next. Parabola, parabola. Let's think about possibilities. Two places. Can they intersect in two places? Yes or no? You bet. Can they intersect in exactly one place? You bet. If it was at the vertex. Can they intersect in no places? So, yeah, that'd be like the red one and the black one. Never intersect. You know what I'm saying? Can they intersect in three places? Not going to happen, right? Either no answers, one answer, or two answer again. Let's substitute. Do I have a variable all by himself? Yep, this is what y equals. I'm going to bring that guy down in here and substitute him for y. So x squared plus shwi x minus 1 . That is a quadratic equation. You want to get them equal to 0 and try to keep the a value positive is usually a good idea also. So move all that stuff over. We'll okay with 3x squared minus x minus 2 equals 0? Cool. Let's talk about him. He's quadratic. He's in standard form. Is there a GCF that can come out? Nope. Easily or frowny face? What is this guy? Frowny face. Put it. Multiply those together. Negative 6, baby. Two numbers that multiply together to be negative 6. Add together to be negative 1. 1 and 6, but one of them has to be negative. No dice. 2 and 3. One of them has to be negative. Bingo. Making that list. I don't know why people are against making the list of multiples. It makes life so much faster. Continue factoring. Substitute back into. I factored, got negative 2/3 or 1. Might as well start with the hard one, negative 2/3. Get that guy down in the first place. So squiggle, 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 x equals negative 2/3. Choose the easier one to substitute into. Remember, the idea behind this is to not use your calculator. Right? Would you use the top one or the bottom one? Who would be easier to substitute into, top one or bottom one? Top one. I don't have to deal with that negative 2 in front of it. So top one, y equals negative 2/3 squared plus 3 times 2/3, negative 2/3 minus 1. All I did was literal substitution into the top equation. I don't know why people are so scared about squaring fractions. It's a number over another number. First of all, when you take a negative number and square it, will it turn out positive or negative? Positive. If you know what 2 squared is and you know what 3 squared is, you better know what 2/3 squared is. 2 squared is 4, 3 squared is 9. What's 2/3 squared? 4 over 9. Cool. 3 times negative 2/3. Boy, I like that, because this times 3 and this divide by 3 are inverses of each other. They cancel each other out. What are you left with right there? Negative 2. Then you have your minus 1 coming down also. Then I need to add these together, so let's get a common denominator. This would be 4/9 minus, turn those guys into 9ths. Turn those guys into 9ths. Then 4 minus 18 minus 9. Four minus 18 is negative 14. Minus 9 more. Just add my numerators together. 4 minus 18, negative 14. Take away 9 more. What'd you get? What's negative 14 minus 9? Negative 23? Does that reduce? Nope. So one of the ordered pairs was negative 2/3, negative 23/9. I want to ask you this question. Do you think your calculator would have gave it to you like that if you would have done second intersect? Does it give you fractions? No. There's a need for this to have exact answers sometimes. Then the other one, piece of cake. X was 1. Y equals 1 squared plus 3 times 1 minus 1. 1 squared is 1 plus 3 more minus 1. 4 minus 1, y equals 3. So 1, 3. Then that is consistent and independent. Cool. Solving systems by substitution. Get a variable by itself first. If they don't have it, substitute that into the other equation. Story time. Here's where I am setting a standard. You will define these variables accurately. There's a reason why you're bad at story problems. You've never taken them seriously. You've never been taught the right way to do them. You read the problem once, and then let's define the variables accurately. So read this problem quick. Let's see what happens. Once you read it through, find the question that they are asking you. It is not that difficult to find the question. They want to know how many rocking chairs were sold. They also have a hard-to-pronounce type of chair, a Adirondack chair. You know, I don't care what that means. It's just a different kind of chair. We've got rocking chairs and hard-to-pronounce chairs. Cool? Do we know anything about them? You know how much they cost, right? How much does it cost for a rocking chair? $265. You know how much it costs for a hard-pronounced chair? It's $320, right? So we know how much they cost. What don't we really know? How many they sold of each, right? So let's define that, right? That's what defining your variable is all about. It's like they want to know how many rocking chairs were sold. Well, I don't know how many rocking chairs were sold. Let's make up a variable for them. What would you like to call it? R would be a great variable for it. How about we let R stand for what? Should it just stand for rocking chairs? What does it stand for? Let's be accurate with it. R stands for the number of rocking chairs sold. Cool. I like it. R equals number of rocking chairs sold. I really like that we chose R instead of X. It brings a little more substance to this. You know, when you're solving for your variables, you kind of know who's who, right? R stands for rocking chairs. What was the other kind of chair? What letter did it start with? A. So I'll call that A equals the number of whatever that word is. The sooner you would have bought into defining things accurately, the easier these problems would have been to understand. R is how many they sold for rocking chairs. A is how many of those chairs they sold also. So let's go back and let's look at some things that are provided for us with a little bit of common sense. I see him, him, and him. Right? I also see him. Your color, please. Those are all the numbers they gave me. Even if I couldn't read a word in here, which I do have the mental capability to read the words in there, but without even reading the words in there, there are 4 things provided. 3 of them have something in common. The 3 pink ones, what's so special about them? Money, money, money. Correct? Let's write a money equation. What is this 265 all about? It's the price of the rocking chairs, right? Now think about it. If you sell 1 rocking chair, how much will you get? $265. If you sell 2 rocking chairs, won't you take $265 times 2? If you sold 10 rocking chairs, won't you take $265 times 10? How many rocking chairs did we sell? We didn't sell 265 of them. How many rocking chairs did we sell? We sold R of them, right? And that's the hard part for people to buy in. It's like, I don't know. Now you do know. You made up a number for it. It's called R. You sold R rocking chairs. At how much a piece? So 265 times however many rocking chairs you sold, right? Again, if I go back to numbers, if you sold 3 of them, wouldn't you figure out you take 265 times 3, and that's how much money you got for it, correct? The other one, I need to add up how many of those hard-to-pronounce chairs I sold. Well, I had A of them sold. How much did I get for each one of them? 320 times every single one of them I sold, right? If you add those together, wouldn't you get all the money that you were accumulated? How much money did they accumulate? $13,930. That number needs a comma with it. Please notice I did not put a $ sign next to any of those. You don't need labels in this. You need just the numbers. Now here's why a system is important. How many variables are in this equation? 2. I can't solve for r without having an a in the answer, right? I've got two different variables. What would be cool is if I could write an entire second equation with the same variables in it, then I could solve a system and figure things out. There was one more number given to me, 48. What is the 48 all about? That's the total number of chairs. Do you know how many rocking chairs they sold? R. Do you know how many hard to pronounce chairs that they sold? A. And together, that's how many? How many chairs did they sold? 48, right? All the rocking chairs we sold plus all the air down chairs that we sold should add up to be how many total chairs we sold. How many total chairs did they sell? So if this is R and A, go in the same order. R plus A equals how much? 48. Now I have a system of linear equations. I can solve this. 3 methods: graphing, substitution, or elimination. I would choose elimination. Don't I have r's on top of each other, a's on top of each other, equals on top of each other, and constants? So let's get something to eliminate. If this is a 265r, what would this have to be to make it go away? So let's take everything down here times negative 265. And then 265 times 48. Right? I'm a big believer in once you've modified this equation, cross them out so it doesn't confuse you. Don't black them out, just cross them out. And now add these two together. What's so great about adding them together? The r's are gone, right? An entire variable gets eliminated. You're left with, help me out, what's 320 minus 265? 55 a's equals, I'll let you punch that in for me also. 13,930 minus that number. $1,210. Like that. 1210. Cool. Now this black equation is awesome. Isn't there just one variable left in it? So how would I solve for A? Divide by 55. You better get an integer back, right? They're not going to sell like 3.8 chairs, right? They sell either 3 chairs or 4 chairs or 5 chairs. So what do you get when you divide that out? 22. Is that what they wanted? The question was how many rocking chairs were sold. How could I figure that out? Substitute back in. I would go into this green thing. Isn't r plus a equal 48? Even though I've kind of modified it, still 48 total rocking chairs sold. 22 of them were hard to pronounce. How many were rocking chairs? So complete sentence. They sold 26 rocking chairs. Or you could say 26 rocking chairs were sold, something in the complete sentence that starts with a capital letter and ends with a period. Define variables accurately, set up 2 equations, solve the system, answer the question in a complete sentence.